These are notes number 8, and you should already have this part done and written down from class. So we're going to go ahead and get started with this part. Okay, so we're learning today how to factor when there is a coefficient in front of the x squared. So this is if there is a number in front of the x squared. You have two ways of doing it. This first way is to see like maybe you can factor it out. So looking at the leading coefficient, maybe you can factor out a 2. Or on this one, maybe you can factor out 36, or maybe there's a greatest common factor you can factor out. So GCF means greatest common factor. We've talked about that quite a bit. It means it's the greatest, the biggest number that divides into every number in the trinomial or every number in the binomial. So these are the steps. So the first thing is to factor out the GCF. Look for the GCF and factor it out. And then after that, you'll have something left, maybe a trinomial like this example, or maybe a binomial. Then you're going to factor what's left if possible. Now, not everything can be factored again, but for my examples, there will be, or you will be able to. So I'm gonna go through this example and then 2 more, and then I'll show you the other way of doing this. All right, so pause if you need to, but I'm gonna go ahead and factor and show you the steps for this first one. It's not numbered though, but for that first one. Okay, so again, if there is a number in front of the x squared, then first see if you can factor it out. So I hope you guys can tell on this first example. Jeez. Sorry, let me try to set this up. Okay, on this first example, I'm looking at the coefficients of 2, 6, and 4, and I can tell right away they're all divisible by 2. So I'm going to set it up and factor out 2, and then that's step 1, and then step 2, I'll see if I can factor what's left, if possible. So if I factor out the 2 from this trinomial, I divide every term by 2. I just have to think 2 times what gives me 2x squared? Well, that would be x squared. 2 times what gives me 6x? That would be 3x, or like I said, divide by 2. Divide 4 by 2, or think 2 times what gives me 4, so that would be a 2. Make sure all your variables and exponents are correct. They didn't change. All I did was divide by the 2. So now I'm going to try to factor out that trinomial to be like x plus something and x plus something else. And just notice that the 2 that I factored out has to stay in front. I didn't mean to leave as big of a gap, but just make sure you leave it in front. That means 2 times that, 2 times that. That's how we'll get the 2x squared and the 6x and the 4. All right, so now I have to just think what times what gives me 2? That adds to give 3. So it's like the normal factoring, like what we've been doing. So I only have one option. 2 times 1 is 2. And luckily that actually works. 2 plus 1 is 3. So my answer would be x plus 2 and x plus 1. I'm going to just rewrite my answer a little bit nicer. X plus 2, x plus 1. The way you check your answer is by multiplying. I didn't really leave room to do that, but you would multiply x. I would start with the 2 binomials and then multiply by 2 at the end. I would do x times x is x squared, x times 1 is x, 2 times x is 2x, and 2 times 1 is 2. So I end up getting 2 on the outside. And then I was saying x squared. I add my 1x and my 2x to get 3x, and then plus 2. And then distribute the 2 to every term and just multiply it. 2x squared plus 6x plus 4. Check and see, is that what we started with? Yes, it is. So again, I think it's easier to check your answer by multiplying the 2 binomials first, kind of like in backwards order of what we did, and then multiply everything by 2. So check, that worked. All right, on this next example, 36 and 16, I want to first factor out the GCF. I can't factor out 36 because 16 is too small. So I have to think about my factors and find the greatest common factor. Let's see, I know I can divide by 2, but I want to think bigger, maybe 4. I know 4 times 4 is 16. 4 times 9 is 36. So I'm going to go ahead and factor out 4. So I would have a 9 left, 9y squared minus 4. And you can tell that was the greatest common factor because out of 9 and 4 on the inside, I can't factor anything else out. So step 1 is done. Step 2, factor what's left if possible. Well, I'm left with 2 numbers, not a trinomial. It's a binomial, but I'm noticing it does have a minus in between. And 9 and 4, they are perfect squares. I'm going to try to write underneath. So I can factor this to be a product of a sum and difference, one with plus, one with minus. And again, that 4 that I factored out stays right in front. It does not disappear. So I can just factor 9y squared to be 3y, square root it. And then the 4 would be a 2 and a 2. So just like what we've been doing, this is a difference of squares. It factors to be a product of a sum and difference. And the 4 that we factored out just stays in front. Okay. And then let's look at the next one. Following our steps, I notice there is a coefficient in front of the x squared. So factor out GCF. I have a 5, 35, and 60. So always start with that leading coefficient, and I actually can factor out a 5. Remember, factoring is like dividing, so it would be x squared. 35 divided by 5 would be 7x, and then 60 divided by 5 is 12. All right, so that might be my final answer, but I have to try. Step 2, it says factor what's left if possible. So I would leave my 5. This is a trinomial, so maybe I can factor it to be a binomial times a binomial. I just have to check and see, okay, 12. Is there anything that multiplies to give me 12 and adds to give me 7? So I'm thinking what times what is 12 that could add to give 7. 1 and 12 would be 13. That doesn't work. 2 and 6 would be 8. That doesn't work. What about 3 and 4? 3 times 4 is 12. 3 plus 4 is 7. Again, order doesn't matter. Could write it whichever way. And if I wanted to check my answer, I would multiply my binomials together doing FOIL or distribute, and then multiply by 5. And what I get after multiplying, it would equal what I started with. It would check out. Okay, so that's one way of factoring when you have a coefficient in front of the squared term. Again, I'm saying x squared, but it could be a y squared or an a squared or a r squared or a t squared, whatever letter, it doesn't matter. Okay, so here is the other way. Pause if you need to. There is quite a bit to copy down. So this is if there is no GCF, if there is no greatest common factor, then do this. These are the steps for ax squared plus bx plus c. I'm going to go through this example and follow these steps, but go ahead and write these steps first right now. Pause it and write them. I'll start explaining and then I'll go over this example. So step 1, multiply first and last. So you do a times c. Also, there's this nice little organizing X, which I can then write my numbers in. So multiply first and last. Number 2, find what factors above add or subtract to the middle term. So the middle term of the trinomial, the b. Let me see if I can put a little more color to this. So b is right there, b goes right there. And then we have, let me get a different color. We have, I'll use red, is pretty different. We have a times c. A times c right there. So you do a times c, put that number at the top. Don't worry about the variables at this point. The middle number, the coefficient part, put that at the bottom. Then you have to find what factors above add or subtract to the middle term. It's the same thought process as like right here, but we're going to write those numbers in the x. Again, it doesn't matter which one goes where. We're going to set it up to be a binomial times a binomial. Whatever your letter is for the variable, you're going to write it first. Depending on the signs, you might have a plus, you might have a minus, you might have 2 pluses or 2 minuses. Just make sure that it's going to work out correctly. So the 2 numbers that you find, they'll go, oops, they'll go there. But this is where it gets different. You have to divide by the a, the number that's in front of the x squared. And I say divide, but it's like make it a fraction. So you divide by it. If you can, go to step 4, reduce the fraction. So like if it was 10 over 2, it would be 5, and you would just write 5. But if it's like 3 over 2, you can't reduce the fraction. So reduce the fraction if possible, then make the denominator, if there is still a denominator, that number would go in front of the x for that one binomial. So divide if you can, reduce if you can. If there's still a denominator, just put it right in front of the x. And it's almost like magic how it works out. This will work. Step 5, check your answer by multiplying. And so I'll show you all those steps for this one right here. All right, so first, pause if you're not done writing, because now you need to be following along. First, you make your x. So if you ever have a coefficient, that a term, and you can't do a GCF, you cannot do the greatest common factor, make an x. Just start by making an x, and then you will hopefully remember from there what to do, or look back at your notes. Multiply first and last. So that is where I would do the 6 times the 5. That gives me 30. I'm going to try to do color so that you guys can see where all the things go. Find what factors above, add or subtract to the middle term. So I'm going to put that middle term at the bottom. So I have to think, what times what is 30? So I put up here multiply. What multiplies to the top and adds to get the bottom? So what you can do, if you don't know your multiplication facts very well, you can just start guessing. 30, I know it's divisible by 2. 2 and 15. Is 2 plus 15 13? No, that would be 17. So that doesn't work. 30 divided by... So you can try to divide by, like, let's just say if you don't know, you can divide by 4, and then it doesn't work. It has to give you a whole number. So 30 divided by 5, that's 6. 5 times 6 is 30. 5 plus 6 is 11. So that doesn't work. So 30 divided by, I missed 3, 10. So 3 times 10 is 30, and 3 plus 10 is 13. So my two numbers are 3 and 10. And again, like I've been saying, like it doesn't matter which one goes where, you could easily switch them. So at this point, I've got steps 1 and 2 done, and I'm on step 3. Again, I'll just color these to make it match so that you can follow along kind of easily, hopefully. So I'm trying to make this look like that so that you can follow the steps right here. I'm at step 3, set it up. So I'm going to put my 2 parentheses, and it's X. So I'm going to make sure is that the right letter here. Yeah, this one does have an X. Start by just putting X like there, and then it's both positives, plus 3 and plus 10. And again, I want to stick with coloring them so you guys can see where everything comes from. Okay. And then I'm going to just review where we got so far. So it's nice to review and kind of think, where did everything come from before I do this next part, which is confusing. Step 1, multiply first and last. 6 times 5 is 30. Multiply to get the top number, 6 times 5. Then the middle number goes to the bottom, 13 on the bottom. What times what? What times what is 30? That adds to give 13. 3 times 10. So again, 3 times 10 is 30. 3 plus 10 is 13. That's how I get my 3 and 10. All right, now is my part where I have to divide by a, or make it a fraction over a. A is 6. So this is one where I can reduce these fractions, but I can't completely divide it. So set it up like this. So it's set up. That is not my final answer. One way you can tell it's not your final answer, imagine doing FOIL. X times x is x squared, not 6x squared. So once you know that it works out multiplying, then you've factored it correctly. So reduce the fraction if possible, then make the denominator go in front of the x. X plus 3 over 6 is 1/2. X plus 10 over 6, you can divide the top and bottom by 2. That would be 5 over 3. So I reduced the fractions, make the denominator go in front of the x. This is a weird step where sometimes people get stuck. The denominator is now a coefficient of the x. Same thing here. If you didn't reduce the fractions, I would have had a 6 and a 6, and I would have got 36. It wouldn't have been the correct number. But now, like I said, it's almost like magic. It actually works out. 2x plus 1, and then that 3 goes in front, 3x plus 5. That should be my final answer. Check your answer by multiplying. Well, let's check it. Let's do FOIL. First, or just distributing, 2x times 3x is 6x squared. Look, that matches right away. One thing I do real quick, like this is just a hint, I just check my first and last. 2x times 3x is 6x squared. My last, 1 times 5 is 5. That's kind of a quick way to see if it looks right. But let's do the whole multiplication. So 2x times 5, 10x. 1 times 3x is 3x. 1 times 5 is 5. Add the two middle terms, we get 13x. And the 5 is still there, and the 6x squared. So if you check it, that is actually correct. So it's a very different way of doing it. It kind of combines what you know already, but it is different. So it takes a lot of practice. Okay, so it checks out. That is correct. So we're going to follow these same steps again, but I have to turn my page. So I might be flipping back and forth. Okay, so pause if you need to finish copying. Pause it now. And I'm going to turn my page. All right, so copy down these two examples. And we're going to just follow the steps. All right, step 1 is to make the x. Oh, actually, step 1, you should always check for the greatest common factor. 4, 8, 3, there's no common factor. 4 and 8, yes, but not with the 3. Then I would multiply. 4 times 3 is 12. My bottom number will be negative 8. So now I have to think, what times what is 12 that adds to give or subtracts to get negative 8? So my factors of 12, if you ever need to list them out, just write them down. 1 times 12, 2 times 6, 3 times 4. Sometimes these top numbers get kind of big, where you'll have to maybe use a calculator. So I have to look which of these would multiply to give 12 and add to give negative 8. So they're going to add to give negative 8. So I know my signs both have to be positive, or sorry, negative. They have to be negative, both negative, to multiply to give a positive and add to give a negative. So it's 2 and 6. Negative 2 and negative 6. At this point, I always check my work before I move ahead. I don't want to like be working and do the wrong work. So I always check my answer to make sure. So negative 2 times negative 6 is positive 12. Negative 2 plus negative 6 is negative 8. So you multiply for the top, multiply, and then add to get the bottom. That's how you check it. And that's how you find the numbers also. Okay, so now we're going to set it up. Make your two sets of parentheses. It's going to be a n. My variable is n, so always watch for that. Minus 2, and then minus 6. But then divide by the number in front of your n squared. So divide by 4. Just like that last one, these don't divide into like a whole number. If it was 8 over 4, it would be 2. But I can reduce both fractions. N minus 1/2, and then n minus, divide top and bottom by 2, it would be 3 over 2. And then just remember your answers, when you factor it shouldn't be a fraction. Your denominators move in front. Denominator moves in front. And we get 2n minus 1. So whatever's left on the top just stays. And then 2n minus 3. Let's check our answer real quick. I don't have a lot of room, but I definitely want to show you that it actually works out. Again, my shortcut is to just check the first and last. So first times first is 4n squared. Last times last, -1 times -3 is +3. But I do want to show you guys FOIL. So check it. So 2n times 2n is 4n squared. 2n times -3 is -6n. Then I've got -1 times -2, -2n, and -1 times -3 is +3. Combine like terms, 4n squared minus 8n plus 3. And if you compare it, that is what we started with. Amazing that it works out. All right, let's do the next one together. And then you'll have some problems to do on your own. So start by setting it up with the x. Actually, I always forgot to say this, but check for a greatest common factor. I made these ones so I know that there isn't one, but you always check 6, 23, and 20. 23 is a prime number, so I know I can't factor anything out. So just start with the steps. The first step, multiply first times last. 6 times 20, if you need to, use a calculator. It would be 120. And then the middle number goes on the bottom, -23. So I can list out some factors, 1 times 120, 2 times 60, 3 times 40. And I want to think as I go, because maybe I'll come up across this one. I want to know what adds to give 23. Okay, so I'm not there yet. None of those would add to give 23. All right, and then 4 times 30, right? Yeah. And then 5 goes into it. 5. I'm doing all this mentally. So remember, you can always use a calculator. 5 times, I think it would be 24. Let me double check. Don't want to mess up on a video. 120 divided by 5. Yeah, 24. Man, there's a lot of factors. And then I'm thinking 6 can go into it. So I do 120 divided by 6. Well, I already know it does. It's 6 times 20. None of those would add to give 23, so I have to keep going. I can check and see 120 divided by 7, but I don't think it goes in. 120 divided by 8 is 15. Okay, I'm going to stop there. 8 times 15. Does that add to give 23? If you're not sure, just check on the calculator. Jeez, my cat is loud. And it does. So 8 and 15, I had to do all that work to get to the right pair. The thing is, though, I have to multiply to give a positive and add to give a negative. So I know that both signs are negative. -8 and -15. All right. So sometimes you can see it takes some work to get there, but we do have our numbers. And now we can start setting it up. So start by setting it up with your parentheses. Okay, and it's a R. I always double check back to the problem. What is the letter? R minus 8, and then R minus 15. But that's not my final answer. R times R is R squared, not 6R squared. So that's the thing that always reminds me, I need to make it a fraction and put that 6 below. Reduce those fractions or divide it completely if you can. So I'm going to separate this a little bit. All right, so I'm going to have R minus divide 8 over 6 by 2. It would be 4 over 3. And then R minus 15 over 6 divided by 3, so 5 over 2. Remember, we don't leave fractions, so those denominators move in front of the R. You can look back at the other problem that we did, and that's exactly what we did. So 3R minus 4, 2R minus 5. That should be the right answer. Just to see if I'm at all close, I always check first times first and last times last. 3R times 2R is 6R squared. -4 times -5 is +20. So that seems right. If you hear my cat, I'm sorry. He's being really loud. So I would just check it real quick. 3R times 2R, 6R squared. 3R times -5, -15R. -4 times 2R is -8R. -4 times -5 is +20. I'm not going to rewrite this because I can tell that I'm right, that I have the right answer. When I combine negative 15R and negative 8R, I do get 23, negative 23. So yes, it does check. So your answer is 3R minus 4 times 2R minus 5. I forgot to circle this one. There we go. All right, so something different, but it is very similar to what we've been doing. Pause if you need this, otherwise I'm going to slide it up. You'll see some of it still, I think. Okay, so here we are. Now, this is your time to practice, show your work, and factor. Okay. Let me move that. Okay, yeah, you can't see it at all. So now show your work and factor. I need to see that you are actually doing the X and that you're putting the numbers in the right spot. I know that there are other ways to do this, but I want you to show me that you understand the method that I just showed, following the steps, okay? So now show your work and factor. Number 1, I have a hint. Factor out 6 first and then see what you can do. This is that number, like the first type of problem where there's a GCF. This is the GCF way. Okay, then 2, 3, and 4, there's no greatest common factor. You're just going to do the steps that we did above. All right, so make sure before you take pictures and turn this in, make sure that you have 1 through 4 done. Make sure you have your 3 questions on the left and a summary. All right, so make sure this is all the way done before you take pictures and turn them in. If I can't read this in your picture, I can't give you credit. You need to make sure these last problems are worked out. It's okay if you're not correct, but I need to see at least that you tried it and that you're putting some of the right numbers in the right spaces. And if you get stuck, well, then that's okay, but at least try to follow the steps like from up above. Okay, so copy that down and finish it. And then when you're all done with questions and 3-sentence summary and all these problems are done, then take pictures and turn it into Google Classroom.